Hi students, welcome to my channel Chemistry by PNSK. In this class, we are discussing about the Bohr's atomic model. What is the topic today? Bohr's atomic model. Before the discussion of Bohr's atomic model, once we are recall the Rutherford drawbacks. Okay, what is the main drawback of Rutherford? He is telling that this is the nucleus, this is an atom, it is an electron. Electron was revolving around the nucleus in a circular manner. Okay, up to that, okay. During the revolution of electron around the nucleus, it loses the energy. Okay, it loses the energy. By the loss of energy, it is fell into nucleus. Okay, but it is not happening here. This entire drawback is overcome by Bohr's atomic model. Let's see the postulates of the Bohr's atomic model. Okay, postulates of Bohr's atomic model. What are the postulates? The first postulate is electron is revolving around the nucleus, in a closed circular paths. Okay. See, let's see the point. This is the nucleus of the atom. These are the circular paths. In circular paths, electron is revolving. Okay. In circular paths, electron is revolving. Okay. Second point. That closed circular paths are called orbits. That closed circular paths are called, he is naming these are orbits. Okay, orbits or shells. In third point, these orbits are having the fixed energy. Okay, the orbits are having the fixed energy. The orbits are having fixed energy. That's why these are called energy levels. These are called energy levels. Okay. Fourth point. He is giving naming to the energy level K, L, M, N or 1, 2, 3, 4. Let's see the fourth point. This is the nucleus of the atom. Okay, this is the nucleus of the atom. These are the closed circular paths, nothing but the orbits. He is telling that these orbits are, first one is first orbit, second orbit, third orbit, fourth orbit. This is the first orbit, second orbit, third orbit and fourth orbit. Okay, this first orbit he is named the K. For second orbit, L. For third orbit, M. And fourth orbit is N. Okay. These orbits are possessing the, this is the electron revolving around the nucleus, right? These orbits are possessing the fixed energy. Okay. How orbits are possessing the fixed energy itself? No. Here orbits are not possessing the energy itself. Here orbits are not possessing energy itself here. How orbits are possessing the fixed energy here? Here orbits are not possessing the energy. Orbits consisting of electron was possessing the energy. That energy belongs to orbits. That's why these are energy levels. Okay, energy levels. Coming to next point. Fifth point, as long as electron revolve around the nucleus in a fixed orbit, it neither loses energy nor gain energy. That's why these energy levels are called stationary orbits. Okay, these energy levels are called stationary orbits. Here stationary orbit means the revolving electron around the nucleus, it does not gain energy or lose energy. That energy is fixed to the orbit. That's why these orbits are called stationary orbits. By providing the stationary orbits, electron does not lose energy and does not gain energy. That's why it does not fall in the, here this is the nucleus and this is the electron in the atom. It does not gain energy or does not lose energy. That's why there is no possibility of falling electron in the nucleus. That is the main drawback of Rutherford, which was given by our favorite scientist Bohr, Niels Bohr. Okay. By providing the stationary orbits, he has overcome the Rutherford atomic model. Okay. Coming to sixth point. In sixth point, he is telling that electron was revolving around the nucleus in a fixed orbit whose angular momentum is equal to integral multiple of the nh by 2 pi. Okay, nh by 2 pi. Here electron is not a easy thing. It is not revolving all orbits. Okay, it is a nucleus. This is an orbits of the atom. Bohr is explaining that sixth point is electron is not revolved in all orbits. Okay, the orbit whose angular momentum is equal to the integral multiple. Okay, integral multiple of nh by 2 pi. Okay. Here electron is not in between the orbits. Okay, in between the orbits. This is the first orbit, second orbit, third and fourth one. Electron not revolved in between the orbits. It is revolving in the orbit whose angular momentum is equal to, here mvr is equal to nh by 2 pi. Okay, that's the sixth point. What is the angular momentum? Let's see. Angular momentum. This is the nucleus. These are the stationary orbits according to our favorite scientist Niels Bohr. Okay, this is the first orbit, second orbit, third orbit, and this is the fourth orbit. Okay, electron is revolving around the fourth orbit. We are assuming that this is a nucleus. In every shell, okay, electron is revolving around the nucleus. The revolving electron with velocity v and mass of the electron is me. Instead of me we are mentioned m only. Okay. The distance between nucleus to electron is nothing but r. Okay. Continuous revolving, here the electron is revolving in a continuously, it makes some angle. Okay, here the angle is with 90 degrees, here also 90 degrees, here also 90 degrees, and here also 90 degrees. Before going to learning the angular momentum, we just recall the momentum. Before going to learn the angular momentum, we have to know about the momentum is mv. Momentum is mv. Angular momentum is mvr because electron moving with some radius from nucleus to outermost cell. Okay, L is the angular momentum is a vector quantity. That's why we are mentioning the bars here. Okay, this is the 7th point. Okay, coming to 8th point. Here Bohr is telling that electron does not revolve in between the orbits or any orbit. Okay, does not revolve in between the orbit or any orbit. When it is revolving, the orbit is angular momentum is equal to nh by 2 pi only. Okay, that is quantized here. Nothing but electron revolution is fixed in particular orbits. That's why it is equal to the integral multiple of the nh by 2 pi. Here electron revolve around the nucleus in a stationary orbit whose angular momentum is equal to nh by 2 pi only. Here n is the integer. Angular momentum equal to mvr equal to nh by 2 pi. This is the formula our favorite scientist provided here. Okay, where m is the mass of electron, v is the velocity of the electron, r is the distance from nucleus to electron consisting orbit. Okay, where n is the integer, n equal to 1, 2, 3 and so on. H is the Planck's constant and the remaining are the constants. Okay, coming to next point. Here remember this is the main equation here. Okay, regarding electron revolution. From this equation we can find the velocity, radius and potential energy, kinetic energy and total energy also. Okay, this is the main equation. Remember this one. Next postulate is eighth one. Here electron does not change the energy during the revolution. Okay, it changes its energy while it is excited or de-excited. Okay, see the point. This is the nucleus, these are the orbits. Okay, here this is an electron. It does not change energy itself. When it is in stationary orbit, it does not change its energy. When it gets to de-excited, it loses the energy. If electron is here, it getting to higher energy level, nothing but excitation takes place, then it changes its energy. Okay, how it changes its energy? During excitation, electron absorbs the energy. Okay, if electron is in first orbit, it gets excited to, this is the first one, second one, third one. Okay, if electron is in first orbit, it gets excited to third orbit by absorbing the energy. Okay, for example, take a staircase. If you are in first step, when you want to go to upstairs, with some energy only we have to stepping into the top. Okay, other than that we are not move very fastly. Okay, that's why here electron also like that. For moving to higher energy levels, it takes some energy and jumps into higher energy level. Okay, as I wish, it get into higher energy level. Okay, yet here it is telling that I am not stable, I want stability by losing energy. Okay, if you went to upstairs, if there is no one, because upstairs is nothing but the free space. Okay, there is no one is there to communicate you, then you want to come down, then you are coming very easily. Okay, likewise here electron also, no, I am not stable here, that's why I lose my energy and get stability by back. Okay, that back movement is nothing but the de-excitation. That back movement is nothing but the de-excitation. During the de-excitation, it is lost the energy. Electron, during the de-excitation, electron loses the energy. Okay, during the absorption of the electron, excitation means electron jumps from lower level to higher energy level. Okay, here from first to third one. Okay, during the de-excitation, vice versa to excitation, nothing but higher energy level to lower level. Okay, that's why by concluding these points, Bohr was providing the delta E is nothing but the E2 minus E1. Okay, delta E equal to E2 minus E1. Here E2 is a higher energy level, E1 is a lower energy level. Okay, when electron jumps from higher energy level to lower energy level, okay, then it changes its energy. Ultimately, orbitary energy also changes. Okay, this is the 8th point here. Have you got my point? Here delta E equal to E2 minus E1. Okay. Here delta E is nothing but hc by lambda. hc by lambda we have seen in previous classes like particle nature of the electron. Okay. Electron is having electromagnetic radiation is having this hc by lambda formula we have seen in electromagnetic radiation is having both the particle nature and wave nature. Okay, from that we are extracting the hc by lambda. Okay, delta E equal to hc by lambda, that equal to E2 minus E1. Okay, 1 by lambda equal to E2 minus E1. E2 minus E1 1 by hc. Okay, E2 minus E1 1 by hc. From this we are extracting this one. Okay, by using this formula, we are finding the wavelength of the electron. Okay, in this Bohr's atomic model we are seeing the mainly two equations that are mvr equal to nh by 2 pi. This is the first one. Here delta E equal to E2 minus E1. E2 is the higher energy level of the electron, E1 is the lower energy of the electron. From this we are getting the hc by lambda equal to E2 minus E1. Okay, hc by lambda equal to E2 minus E1. Okay, from this we are getting the lambda 1 by lambda equal to E2 minus E1 into 1 by hc. Okay, by using this wavelength of the electron also we are finding. This is the 8th point. Coming to 9th point, remember this formula and this formula also. This also used for calculating the wavelength of the electron with reference to energy. Okay, coming to 9th point. 9th point is when number of orbits increases in between the successive orbits, energy is decreasing. This is the nucleus, first one, second one, third one, fourth one, fifth one. By increasing the number, energy is decreasing. Okay, as per Bohr, in between the first one, second one, third one, fourth one, fifth and sixth, the energy between the first and second is more compared to third and fourth. Okay, the energy between first and second is more compared to third and fourth, or third and the energy difference between first and second is more than second and third. Okay. Coming to next one, the energy difference between second and third is more than third and fourth. He is telling nothing but number of orbits increases, energy decreases. Okay, the successive orbits increase, nothing but energy decreases. Okay, during the revolution of electron, this is the nucleus, these are the orbits, this is the electron, there are electrostatic force of attractions are there. Electrostatic force of attractions are there. By equating each forces, we are getting another formula. Let's see that one also. Here electron moving towards the nucleus force is centripetal force. Away from the nucleus is centrifugal force. According to Coulomb's law of force, Coulomb's law of according to Coulomb's law, F equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Okay, from this we are getting 1 by 4 pi epsilon naught into Q1 is the charge of the nucleus and Q2 is the charge of the electron. Then we are writing Z into E. Here Z is 1. Okay, by R square. From this we are simplifying 1 by 4 pi epsilon naught into Z square by R square. This is the centripetal force. Centrifugal force equal to mv square by R. Okay, this is the equation 1. This is the equation 2. By equating both equations, we are getting 1 by 4 pi epsilon naught into Z into E square by R square equal to mv square by R. Okay, mv square by 1. Here 1 equal to 2. From this, we are calculating R terms. Okay, what is remaining here? 1 by 4 pi epsilon naught into Z square by R equal to mv. Okay, this is the main formula by centripetal force and centrifugal force. By this formula and mvr equal to nh by 2 pi formula, we are by using these two formulas we are getting the velocity of the electron, radius of the electron, potential energy of the electron and also kinetic energy of the electron. By totaling them, we are getting the total energy of the electron. Let us discuss the radius of an orbit which is provided by formulas from the Bohr's. Okay, what we are finding here? A radius. What is the final equation regarding the centrifugal force and centripetal force of the electron? That is mv square equal to 1 by 4 pi epsilon naught into Z square by R. Z square by R. From this we are getting the V square that equal to 1 by 4 pi epsilon naught into M into Z square by R. Okay. This is the V square from force of attractions of the electron. Okay. From angular momentum also we are deriving the V's velocity, that is mvr equal to nh by 2 pi. Okay, squaring on both sides, this is the equation 1. Squaring on both sides, m square v square r square equal to n square h square by 4 into pi square. 2 square is 4. Okay, this is the equation 1. From this we are getting a v square equal to n square h square by 4 pi square into, from this we are getting the v square, that is v square equal to n square h square by 4 pi square into m square r square. M square r square. This is the equation 2. By equating equation 1 and 2, v square equal to, from one equation 1 by 4 pi epsilon naught into m, z square by r is equating by this value. Okay, let's see what is happening here. 1 by 4 pi epsilon naught into m into z square by r equal to n square h square by 4 pi square m square r square. Okay, here r, this r is cancellating, square of m is cancellating, This pi square and this pi also cancelling. 4 are cancelling. What is remaining here? Z square by epsilon naught. Z square by epsilon naught equal to n square h square by pi into m into r. Okay. From this we are multiplying with r by z square and this can be converted that side. Then z square r equal to n square h square by, okay, this epsilon naught come to this side, epsilon naught by pi into m. Pi into m. Okay, from this we are getting r. R equal to n square h square epsilon naught by pi into m into z square. Okay, here it is in multiple side, that becomes this side denominator. Okay, okay. From this, in this equation, except n square and z, remaining all are constant. Okay, here n is an integer is variable and atomic number also variable. From this we are writing, have you noted this? From this we are writing r equal to h square epsilon naught by pi into m into e square. Pi into m into e square by pi into m into e square into n square by z. Okay, by applying all these constants we are getting 0.53 into n square by z in electron volts. Okay, this is the final formula for finding the radius of the orbit. Okay, radius of the orbit. Let us come to the example model calculation. Example, finding the first 3 orbits radius of hydrogen atom. First 3 orbits radius of hydrogen atom. Okay. Sorry, 0.53 n square by z in angstroms. Okay. Next, by using this formula, okay, by using this formula, we can calculate the first radius of the first 3 orbits of hydrogen atom. For first orbit, n equal to 1, z equal to 1. What is the formula? R equal to 0.53 into n square by z in angstroms. Okay, 0.53 into for first orbit. What is n? 1 square by 1. That is equal to 0.53 angstroms. This is for first orbit. Next, for second orbit, same. R2 equal to 0.53 into second orbit n equal to 2. Z equal to same 1. That is 2 square by 1. Then we get 2.11. Then we get 2.11 angstroms. R equal to 2.11 angstroms. For third orbit, R3 equals 0.53 into, for third orbit n equal to 3 into 3 square by 1. That is 0.53 into 3 square is nothing but 9. We are getting 4.4 we are getting approximately 4.76 angstroms. Okay, this is the R3 for hydrogen atom. For first orbit radius is 0.53 angstroms. For second orbit radius is 2.11 angstroms. For third orbit radius is 4.76 angstroms. Okay, this is for K shell, this is for L shell, and this is for M shell. Likewise, the radius of the electron is found in hydrogen and hydrogen-like atoms. Okay, after that, after the radiation derivation, we should see the velocity of the electron. Next, derivation for the velocity of the electron. Velocity. This velocity also finding from the same equations. Okay, centripetal equation and angular momentum equations. Okay. Here, what is the R value from radius of the electron? R equal to n square h square epsilon. N square h square epsilon naught by pi m into z square. Okay. Pi m r equal to n square h square epsilon naught by pi m into z square from derivation of the radius. Okay. What is the angular momentum derivation? mvr equal to nh by mvr equal to nh by 2 pi. Okay, place the r value in the equation. M into v into r value is n square h square epsilon naught by pi into m into z square, that equal to nh by 2 pi. Okay, nh by 2 pi. Is there any cancellations? Yes. Pi is cancelled. Okay. H is cancelled. N is cancelled. And one more, m and m also cancelled. What is remaining here? V into n into h into epsilon naught by z square, that equal to 1 by 2. Crisscross. From this we are writing V equal to Z square by 2 into n into h into epsilon naught. Okay. From this V equal to, here Z and n are variables, E square by 2 into h into epsilon naught. Okay, in brackets Z by n. Okay, Z by n. From this, calculating all values, we are getting 2.186 into 10 power 6 Z by n meter per second. This is the velocity for finding the electron velocity in Bohr orbit. Okay, let's take an example, that is calculate the second orbit velocity of the helium. Second orbit velocity of the helium. Okay, let's see. What is the formula here for finding the velocity? Velocity equal to 2.18 into 10 power 6 into Z by n meter per second. Okay, Z by n meter per second. What is the n value here? N equal to 2. Then what is the Z? Helium Z is 2. Helium atomic number is how much? 2. So 18 into 10 power 6 into 2 by 2, that is 1. Then V equal to 2.18 into 10 power 6 meter per second for finding the velocity of second orbit of the helium atom. Likewise in the exams asking the questions, then we are placing this formula. Okay, after the finding of radius and velocity, we have to move to kinetic energy, potential energy and total energy of the electron present in the orbit. Okay. First one, kinetic energy of the electron in the orbit. This derivation is kinetic energy equal to half into mv square. Okay, place the v value here. What is the velocity we are finding for electron derivation? V equal to ze square by 2 epsilon naught nh. Okay, place this value here. Then kinetic energy equal to 1 by 2 into m into ze square by 2 epsilon naught n into h whole square. Okay, squaring the terms, then we get kinetic energy equal to 1 by 2 into m into 1 by 2 into m into z square 2 into 2 4 e power 4 by 2 2s are 4 into epsilon naught square into n square into h square. N square into h square. From this we are simplifying kinetic energy equal to m into z square e power 4 by 2 4s are 8 into epsilon naught square into n square into h square, n square into h square. In this, except z and n, remaining all are constants. Then kinetic energy equal to m into e power 4 by 8 by epsilon naught square h square into z square by n square. Okay. From this, applying the values, we are getting kinetic energy equal to 3.16 into z square by n square in electron volts. Okay, this is the kinetic energy for finding the electron in orbits. Okay, the electron radius is derived here, velocity is derived here, and kinetic energy also derived. Let's take an example calculation. Finding the kinetic energy of the hydrogen in second cell. Okay, finding the kinetic energy for electron in second shell of hydrogen. Second shell of hydrogen. Let's see how much it is become. Here what is the n? 2, because it is second cell. Hydrogen Z is 1, atomic number is 1. By placing these two values here, then kinetic energy equal to 3.16 into Z square by n square. That is 3.16 into what is the Z? 1 square by n square 2 square, that equal 3.16 into 1 by 4. Okay. From this we are getting 0.79 electron volts. Okay, what is the kinetic energy for second shell here? 0.79 electron volts. By using this formula we are finding the kinetic energy of the electron in orbit. Okay. After kinetic energy, we have to find the potential energy also. Next, potential energy, electron jumps from higher energy level to lower energy. At higher energy is 16 joules. When it is jumping to lower, then it becomes 3 joules. Okay, then it becomes 3 joules. For de-excitation, we are writing the potential energy equal to minus F into R. Okay, here minus is the loss of energy by the electrostatic force of the electron and nucleus. That's why we are mentioning here negative sign. Okay, what is the electrostatic force here? 1 by 4 pi epsilon naught into 1 by 4 pi epsilon naught into Z square by R square into R. Mention the negative sign definitely. Okay, here R and R get cancelled, then we are having minus 1 by 4 pi epsilon naught into Z square by R. Okay, from this we are writing what is the R value? R equal to epsilon naught n square h square by Z square into pi into m. Okay, this is R which is finding from derivation of the radius. Okay, just write the reciprocal of the R. 1 by R equal to Z square into pi into m by epsilon naught into n square h square. Okay, here we are writing the formula potential energy equal to negative sign of Z square by 4 pi epsilon naught into 1 by R we are seeing here. This seems to be like 1 by, Z. Here this seems to be Z square by 4 pi epsilon naught into 1 by R, right? This 1 by R is nothing but reciprocal of the radius we are mentioned here. Then we are writing minus Z square by 4 pi epsilon naught into, what is the 1 by R value here? Z square pi into m by epsilon naught into n square h square. Okay, have you got my point? Let's see any cancellations here. Here pi and pi are cancelled. Okay, after that what? Remaining all we have write potential energy equal to minus Z square by 4 epsilon naught into Z square into m by epsilon naught into n square into h square. Okay, from this potential energy equal to Z square e power 4 e square into e square e power 4 into m by 4 epsilon naught square n square h square. Okay, except z square and n square remaining all are constant, then we are writing potential energy equal to e power 4 into m by 4 epsilon naught square into h square in brackets into z square by n square. By applying in the all constants, we are getting the value is sorry to forgot mentioning the negative sign. Okay, minus here also mentioning the negative sign, I forgot it. Okay, minus 27.2 into z square by n square electron volts. This is the potential energy formula for finding the electron in the orbit. Let's take an example calculation. Calculate the potential energy of electron in third orbit of hydrogen. third orbit of hydrogen. Then we are placing the formula potential energy equal to minus 27.2 into what is that? Z square. Z is 1 square. N, how much N here? Third one. 3 square. Okay. Okay. From this we are getting, by calculation we are getting the answer here. Okay. How much the answer here? Minus 3.02 electron volts. Because 3 square become the 9. 9 in 3 tens of 27. Okay. After finding the potential energy and kinetic energy, we have to equate the total energy of the electron here. Let us see the another derivation, which is the total energy of the electron. Okay. Here finding the calculation derive the calculation for the finding of total energy. Total energy equal to nothing but potential energy plus kinetic energy. Potential energy equal to minus Z square epsilon naught 4 m by, potential energy equal to minus Z square e power 4 by 4 epsilon naught square n square h square plus, what is the kinetic energy? Kinetic energy equal to Z square e into m by 8 epsilon naught square n square h square. Okay. Sorry to forget mentioning e power 4 into m by 8 epsilon naught square n square h square. Fractioning the both equations, we are getting minus Z square e power 4 m by 4 epsilon naught square n square h square into 1 minus 1 by 2. Okay, 1 minus 1 by 2. Okay, by simplifying this we are getting, from this simplifying, total energy equal to minus Z into e power 4 m by 8 epsilon naught square n square h square. Here Z and n are constant. By separating them, total energy equal to minus e power 4 m by 8 epsilon naught square h square into Z by, this entire value is become minus 13.6 into Z by n square. Okay, minus 13.6 into Z by n square. This is the total energy of the electron. Okay, total energy of the electron. This is nothing but for hydrogen atom. Okay, understand? Have you got my point? For that only, in previous class of hydrogen spectrum, we are discussing that total energy of the spectral lines total energy of the spectral lines is nothing but the 13.6. This is the value. Okay, by increasing the shells, this value is decreasing, energy decreasing. Okay, by this, using total energy derivation, we have to calculate the total energy of the electron in which shell. Okay, either 1, 2, 3 and so on. Here n is the integer number of the shells. Okay, by using these derivations, we are calculating the first one, radius of the electron. Okay, next one, velocity of the electron, potential energy of the electron, kinetic energy of the electron, and from these two we are calculating the total energy of the electron also. Okay, this is the conclusion for the derivation and calculations. Okay, after this we are learning about what are the drawbacks in the Bohr's atomic model. Okay.